Hello everyone, this is Jeff Amboy and welcome to my lecture series in physics. In this episode, I will discuss the concept of electric fields, including its definition and properties. Then, we will solve several problems involving the calculation of electric fields of point charges and the motion of a charged particle in the presence of a uniform electric field. But before that, let me discuss the background pictures here in the first slide. So you can see here a ball that glows. This ball is called a plasma ball. Usong-uso yan noong 1980s. Novelty item yan, okay? It contains some noble gases inside it, usually neon or argon. So ang nangyayari dyan is parang yung nangyayari lang din sa mga neon lights. 'Di ba? Nag-glow sila. Sa loob ng glass, napakataas ng electric field. So that extremely high electric field causes a corona discharge, which we see as these glowing filaments emanating from this small sphere at the center of the ball. So bakit nagkakaganon? Okay, let me explain. Air is naturally an insulator and it doesn't usually conduct electricity. However, it may break down due to an extremely high electric field. Ayan, kung meron pala tayong mataas, extremely high na electric field, kagaya ng nangyayari dito sa plasma ball, mataas yung electric field sa loob, yung air na insulator ay nagbe-breakdown. So ito ang nakikita natin dito ngayon. So kapag ka nag-breakdown niya, nagko-conduct yung insulator. The gas atoms are ionized and then they glow. And remember, ionized gas is called plasma. 'Di ba? That's why this ball is called a plasma ball. So you can think of this as a lightning. Parang kidlat na nasa loob ng isang glass. Siyempre, if you touch the surface of the glass, hindi ka naman makukuryente kasi yung glass ay insulator. However, parang susunod yung filament na umiilaw dun sa kamay mo. Why? Because your hand is more conductive compared to the air. That's why it will tend to follow your finger, Kasi nga again, mas conductive siya. Now, the other picture shows how these two ladies are electrified. So, the word electrified here doesn't mean na kuryente ang dalawang babae. Ibig sabihin lang nun, nagkaroon ng transfer of charges. Okay? So, bakit tumitirik ang buhok at naninindig ang buhok ng dalawang babaeng ito? This is because the electrons have been transferred into their bodies from this metallic surface. Okay? Some of these electrons went to their hairs, and because they are all negative, syempre negatively charged ang electron, what will happen to them? Di ba magre-repel sila? Okay, so here we see that these hair strands are standing, Tirik-tirik yan. Because they have electrons. An excess of electrons repelling each other. That's why we see such effect on the hair strands. Diba? Naninindig. Nagtayuan yung mga buhok, But it doesn't mean na kuryente sila. Again, the word electrified only means nagkaroon ng transfer of charges. Now, in this case, mga electrons yung na-transfer mula dito sa metallic structure na ito. So, these pictures give us an idea of the topic that we will be discussing, which is all about electric fields and electric charges. Okay, so let's begin our discussion. We'll start with the concept of the field. If a test charge is brought near a source charge, this test charge experiences a force. We know that because of Coulomb's law, di ba? For example, ito yung tinutukoy natin na source charge at ito namang pula ang ating at itong kulay pula, ito naman yung test charge. Okay? So sa pagitan nila, alam natin may force. It could be repulsive or attractive depending on whether these two charges are positive or negative. And again, we can use Coulomb's law to quantify the force between these two electric charges. But we may also ask, why is there a force between these two objects that possess electric charge? O nga, Is that a valid question? Yes, actually, Bakit nga ba may force sa pagitan ng dalawang bagay na ito na nagtataglay ng electric charges? Kasi maiisip mo bakit may force sa pagitan nila? Wala naman silang physical contact sa isa't isa, 'di ba? When we talk about forces in mechanics, usually, there are physical contacts involved. 'Di ba? Sa mechanics, yung mga forces na pinag-aaralan natin usually nag-i-involve ng physical contact. However, in this case, these two objects are apart from each other. So walang physical contact, no? Eh bakit may force? 'Di ba? This is where the concept of the field comes in, no? Because in physics, aside from contact forces, there are also field forces. Sir, ano yung mga field force? Isang halimbawa ng field force ay ang force sa pagitan ng dalawang electric charges na ito. And the existence of this force can be attributed to an invisible entity which is called a field. No? And since we are talking about electric charges, then it's only proper that we call this field the electric field. No? So kaya ang tawag natin, electric field. So yun palang force na nararamdaman ng dalawang charges na ito, whether it's repulsive or attractive, can be attributed to this electric field. Yes, no? At yung electric field na yan nanggagaling dito sa source charge. We can compare this situation to a previous topic in mechanics which is about gravitation. No? For example, the Earth and the Moon. Ayan, this is the Earth and this is the Moon. Dito araw, dito gabi. Nung isang araw wala akong magawa, kaya ang ginawa ko, pumunta ako sa outer space and took this photo so I can put it in this PowerPoint slide. Sakay ako sa SpaceX ni Elon Musk, 'di ba? Social, close kasi kami, no? Yan. So dapat marami kayong connections, no, para mas marami kayong nararating. We know that the Earth exerts a gravitational force on the Moon. And likewise, the Moon also exerts a gravitational force on Earth. Ang pinagkaiba lang sa force of gravity, ang force ay laging attractive, no? Wala namang force of gravity na repulsive. Unlike kapag electric charges ang pinag-uusapan, di ba? We know that like charges repel and unlike charges attract. But again, if we're talking about gravity, the force is always attractive. And since both the Earth and the Moon exert force towards each other, then it's also correct to say that they affect each other. Diba? But how can they affect each other when they are separated by a huge distance? Diba? Ang layo-layo kaya ng Moon sa Earth, no? So wala namang physical contact yung dalawa. Paano nangyayari na naaapektuhan nila ang isa't isa? Diba? Because of that, maiisip mo, no? 'Di ba? Mayroon silang connection. Somehow, these two bodies, the Earth and the Moon, somehow must be connected to each other. As in connected, quote-unquote. Bakit? Kasi wala naman talaga tayong nakikitang physical connection sa pagitan nila. 'Di ba? Wala namang tali sa pagitan ng Earth at saka ng Moon. So, bakit sila affected ng isa't isa? Ano? Bakit nga ba sila affected? Parang ikaw, no? Affected na affected ka kapag kayong classmate mo nagpo-post, 'di ba, sa Facebook o kaya sa Twitter. So bakit ka affected? Ano ibig sabihin nun, 'di ba? Ibig sabihin lang nun may something, 'di ba? Ano meron sa inyong dalawa at affected na affected ka sa kanya, no? So kung walang something, hindi ka maapektuhan. But the mere fact na affected ka, may something in between, 'di ba? So ganun din sa pagitan ng Earth at saka ng Moon. Ganun din sa pagitan ng dalawang electric charges na ito. Again, ang nagko-connect sa kanila ay ang invisible entity na tinatawag natin na field, no? In the case of the Moon and the Earth, ang tawag ay gravitational field at sa pagitan naman ng dalawang electric charges na ito, ang nagko-connecta sa kanila ay ang electric field. Now, going back to the Earth and the Moon, saan ba galing yung gravitational field? Di ba? Actually, it's created by the Earth by virtue of its mass. However, you may also say that just like the Earth, the Moon also has mass. Diba? Kaso nga lang mas maliit. That's right. Okay? So does the Moon generate its own gravitational field? Yes. And the interaction between the gravitational fields of the Earth and the Moon result to the force of attraction between them. Yun naman pala, no? Yung interaction sa pagitan ng gravitational fields ng Earth at ng Moon ang dahilan kaya may force of attraction sa pagitan ng Earth at ng Moon. Amazing grace. Thus, we can say that the gravitational force is a field force. And field forces can act through space. Again, why is gravitational force a field force? Because it acts through the gravitational field. And remember, field forces can act even through the emptiness of space. However, yung space sa pagitan ng Earth at saka ng Moon, hindi naman talaga totally empty yan. Bakit? Kasi alam natin, sa pagitan nila, meron ngang invisible na gravitational field. No? So therefore, it is more accurate to say that the gravitational force acts through the gravitational field. Now, in the case of these two charged objects, the force between them may be attributed to the presence of an electric field. At saan naman galing yung electric field? The electric field is generated by the objects by virtue of their charges. In the same way that the Earth and the Moon have gravitational fields due to their masses. The more massive a body, the greater is the gravitational field, no? So because the Earth is more massive than the Moon, mas malakas ang gravitational field ng Earth. And likewise, the greater the magnitude of the charge, the stronger is the electric field for electric charges. And just like the gravitational force, the electric force between these two charged objects is also an example of a field force. No? So ganoon pala, no? Kaya naapektuhan ng dalawang bagay ang isa't isa kahit magkalayo sila kasi nag-i-interact sila through a field. Again, kapag Earth-Moon, gravitational field, at kapag mga electric charges naman ang involved, they interact through the electric field. Kaya may force sa pagitan nila. No? And this field seems to connect these two objects, no? In the same way that the gravitational field seems to connect the Earth and the Moon, no? So we say that when an object in one place affects something at a different location, we say that these objects are being connected by a field. And the effect of the field is produced even with no physical contact between these objects. Kaya nga ang tawag natin dun sa force ay field force, no? So the concept of the field was actually developed by Michael Faraday, that is in terms of electric fields, no? So how do we define a field? A field is defined as a function that is used to specify the spatial distribution of a physical quantity. Sir, anong ibig sabihin nito? Ibig sabihin lang yan in a mathematical point of view, no? The field is a function, no? Pwede natin siyang express mathematically. That mathematical function specifies how a certain physical quantity is distributed in space. Ayan. Para bagang sa gravitational field, no? Paano naka-distribute ang gravitational force sa space? No? In the case of electric charges, how is the electric force distributed in space? That is described by electric fields. No? And fields can either be scalar fields or vector fields. For example, the temperature distribution in a room can be thought of as a scalar field. Why? Because temperature is a scalar quantity. Ano? And we know that in a room, iba-iba ang temperature sa iba't ibang parts, 'di ba? Halimbawa, doon sa sulok ng room, iba ang temperature niya kumpara doon sa gitna ng room, 'di ba? So, ano ang temperature ng iba't ibang parts ng room? That can be expressed in terms of a field which we call the temperature field. And that is an example of a scalar field. Now, for vector fields, ang halimbawa niyan ay itong field sa pagitan ng mga charges yan. Electric field is a vector quantity and likewise, gravitational field is also a vector quantity. Why? Because they are associated with forces and we know that force is a vector quantity. Now, I have a question. What if I remove this red charge which acts as the test charge? Mawawala kaya yung electric field? Diba? So parang sinabi mo na rin na kung tatanggalin ko yung moon, mawawala kaya ang gravitational field? Diba? So parang yun yung analogy eh. Kahit tanggalin natin ang moon, hindi mawawala ang gravitational field kasi yung Earth ay nagge-generate ng sarili niyang gravitational field. So kung ang test charge na ito tatanggalin natin, we can also justify that the electric field will not disappear. Why? Because this object possesses a charge. And because it possesses charge, it will generate its own electric field. Kahit pawala itong test charge na ito. Okay? So what's the purpose of this test charge? Later, I will explain it to you. Okay? But one thing is important na na-realize natin dito, no? Again, kapag tinanggal ko itong test charge, hindi mawawala ang electric field kasi itong object na ito ay nagtataglay ng charge. And because it possesses charge, it generates an electric field in a region surrounding it. So therefore, saan ang gagaling ang electric field? We can conclude that electric fields come from electric charges. Now, after this, let us discuss the formal definition of the electric field. In the previous slide, we have learned that an electric field always exists in a region of space surrounding an electric charge. For example, again here, we have a source charge. This spherical object possesses a net positive charge. In the region surrounding it, there must be an electric field, right? So to visualize that electric field, naglagay tayo dito ng isang vector. This vector represents the electric field at this point, no? Point P. So now, what if we want to determine the electric field at this point? Diba? Paano natin malalaman kung gaano kalaki ang electric field sa point na ito? Anong gagawin mo? Maglagay ka lang ng test charge dyan sa point na yan. Kapag naglagay tayo ng test charge, makakaramdam siya ng force. That is because of the electric field that's generated by the source charge. So ngayon, naglagay na tayo ng test charge. Nakaramdam siya ng force. Paano natin malalaman kung gaano kalaki yung electric field? That leads us to the very definition of the electric field. No? We define electric field intensity or simply electric field, no? The formal name of electric field is electric field intensity, and it is defined as the force per unit charge. So anong ibig sabihin nito? In the definition of the electric field, kinakailangan talaga natin ng test charge, 'di ba? Bakit? Para ma-measure natin yung force. Bakit naman kailangan ng force? Kasi gagamitin natin yung force para makalculate yung electric field. Why? Because electric field is the force per unit charge. So take note of this very important formula. This is a definition. Kaya naman sa halip na equal sign, 3 bars ang makikita natin dito. Okay? Definition ito ng electric field. Again, we define electric field as the force acting per unit charge. At yung charge na tinutukoy, that is essentially a test charge. Ayan. So itong force na ito yung Fe. Yan yung electric force, no? At yung electric force na yan, i-divide mo lang ng magnitude ng point charge, malalaman mo na ang electric field. 'Di ba? So dito, ano pala ang role ng test charge? 'Di ba? Ang role ng test charge is para ma-measure natin yung electric field. Bakit? Kasi to measure the electric field, we need the force, no? At para may makaramdam ng force, kinakailangan maglagay tayo ng test charge. We know kasi kahit walang test charge dito, meron tayong electric field, 'di ba? Kasi yung electric field naman dito nang gagaling sa source charge. Alam natin may electric field, pero alam lang natin 'yon. Kung gusto mong i-measure ang electric field, kailangan mo ng test charge. Kung gusto mong maramdaman yung electric field, kailangan mo ng test charge. Kung gusto mong ma-prove na talagang may electric field, kailangan mo ng test charge. Sir, paano natin mapuprove na may electric field? Kapag naglagay ako ng test charge, the proof is when you put a test charge here, yung test charge makakaramdam ng force. So the fact na siya ay nakaramdam ng force, that is an indication that there is an electric field in that region. Okay? So, ibig sabihin pala niyan, we can describe electric field as a region of space kung saan ang isang test charge ay nakakaramdam ng electric force. Yes, that's correct. Okay? Now, ano ang unit ng electric field? From its definition, the electric field would have a unit of a force divided by the unit of charge in SI system, that is newtons per coulomb. However, there is an equivalent unit which is also used, no? And it is volts per meter. So in physics, usually ang unit niyan ay newtons per coulomb. But in electromagnetics, mas ginagamit yung volts per meter. Now, kung babalikan natin itong test charge na ito, we know that it also possesses a charge, right? And because it has a charge, pwede rin natin sabihin na nagge-generate din siya ng sarili niyang electric field. Yes. That's right. So, posible pala na yung electric field ng test charge ay makaapekto dun sa mini-measure natin na electric field galing sa source charge. Yes. No? Kaya ang ginagawa natin is, as much as possible, we keep the magnitude of the test charge as small as possible. No? Para yung kanyang electric field hindi makadisturb or makaapekto dun sa electric field na iyong mini-measure. And because of that, pwede nating i-define ang electric field in a more accurate manner. Ano? Electric field is equal to the limit of F over Q naught, no? As Q naught approaches 0. Ayan. So dito, sa expression na ito, in-indicate lang natin na dapat yung magnitude ng test charge ay maliit lamang, no? Pero hindi pwedeng 0. Bakit? Kasi kung yan ay 0 na, ay wala na siyang charge, di ba? Okay. Meron siyang charge, pero maliit lang. Ano? Nag-a-approach sa 0. Bakit? Kasi ayaw natin na yung electric field ng test charge ay makaapekto dun sa electric field na ating mini-measure na nanggagaling naman doon sa source charge. Okay? So, this is a more accurate definition of the electric field. However, this one will do. Ano? Yung force per unit charge. Tandaan nyo mabuti ha, electric field is defined as the force per unit charge. And here's one more thing about test charges. By convention, a test charge is always a unit positive charge. Kaya kung napansin mo, isang plus lang yan. No? Ang ini-indicate niyan, ang charge niya, ang magnitude ay unity. Okay? At lagi siyang positive. A test charge is always a unit positive charge. Now, what if there is an electric field in a region and I put a test charge? How much force will that test charge experience? So, mula sa definition ng electric field, makukompute natin yung force. Ano? Yung force equal dun sa test charge, mumultiply mo lang siya nung electric field na kanyang nararamdaman. Okay? So, once again, the electric force acting on a test charge. For example, the test charge is simply Q at siya ay inilagay mo sa isang region na may electric field E, makakaramdam siya ng force na equal sa Q times E. Okay, tatandaan po ha, itong force is equal to QE, galing lang ito doon sa definition natin ng electric field. No? So kung iyong mapapansin, may analogy iyan sa mechanics, 'di ba? Kanina, yung analogy natin ng mass ay yung charge, 'di ba? So itong formula na ito ay analogous din dun sa formula na F is equal to mass times acceleration, 'di ba? Because Q is equivalent to mass. Diba? So, anong field ang involved sa mechanics? Ang field na involved ay acceleration. For example, acceleration due to gravity. Diba? Dito naman, ang field na involved ay electric field. Okay? Ibalik lang natin yung source charge ha. Ito yung source charge na natataglay ng net positive charge. Naglagay tayo dito ng test charge at itong test charge ay positive. Nakaramdam naman siya ng force. Kung mapapansin natin, the force is in the same direction of the electric field. And the electric field is directed away from the positive source charge. Dito naman, naglagay tayo ng special na test charge. Ginawa natin siyang negative. No? So, ano ang nagbago? Mapapansin natin na yung electric field ay directed pa rin away from the source charge. Okay? Tapos, yung force ngayon, opposite na yung direction. Ganun pala yan. Kapag ang nakakaramdam ng force mula sa electric field ay isang negative na charge, ang direction ng force na kanyang nararamdaman ay laging opposite sa direction ng electric field. Ano? So, tatandaang mabuti ha, ang force na nararamdaman ng mga negative charges kagaya ng electrons ay laging opposite sa direction ng electric field. Pero ano ang common dito? Ang common dito, yung direction ng electric field. 'Di ba? Ang direction ng electric field ay pakanan. So, pwede tayong mag-conclude dito, no, na kapag positive ang source charge, ang electric field ay directed away from the source charge. Okay? Now, pag tinanggal natin itong mga test charge na ito, alam natin na hindi mawawala yung electric field. Why? Because the electric field is a property of the source charge and not the test charge. Kailangan lang natin yung test charge para ma-prove na may electric field doon sa region na yun. No? Paano again mapuprove? Kapag naglagay ka ng test charge, yung test charge ay makakaramdam ng force. And that force is a proof na may electric field. So once again, yung test charge ay ginagamit lang natin para ma-detect yung presence ng electric field. But even without these test charges, we know that in the region surrounding this Q, mayroong electric field. Okay? One more thing, tatandaan po yung direction ng electric field. Kapag positive ang source charge, electric field is directed away from the source charge. So sir, what if itong source charge, gawin ko naman siyang negative? Itong electric field na ito, magre-reverse yung direction. Yung direction niya magiging towards the left na. So therefore, we can have a conclusion that electric fields are always directed away from positive charges and points towards negative source charges. Tandaan, away from the positive towards the negative. That is always the direction of electric fields. Tandaan po natin yun, ha? Now, let's talk about the electric field generated by a point charge. Sir, what is a point charge? Kapag ang charge na pinag-uusapan natin ay maliit ang size kumpara dun sa mga dimensions na involved, no? Then that tiny charge can be considered or modeled as a point charge. Halimbawa, ang pinag-uusapan natin ay isang maliit na sphere na ang size ay millimeters. At ang distances na involved ay meters, 'di ba? Napakalaki ng meter kumpara sa millimeter. And because of that, yung dimension na pinag-uusapan natin ng charge ay pwede nating i-model as a point charge. Kasi napakaliit niya kumpara dun sa given dimension, which is measured in meters. Okay? So, yun yung point charge. Now, for example, we have a point charge here, no? It possesses a net charge Q. At gusto nating malaman ang electric field sa point na ito. Okay? At ang point na yan, gaano kalayo mula sa point charge? Siya ay may layong R. Anong gagawin natin para malaman yung electric field? Di ba from the definition of electric field, kinakailangan natin ditong maglagay ng isang test charge. Ayan, maglagay tayo ng test charge. For example, ang test charge ay may magnitude na Q. Okay? Ano daw ang kailangan nating gawin para malaman yung electric field? 'Di ba sabi kanina, we need to measure the force and divide the force by the charge. So, with the use of Coulomb's law, mame-measure natin yung electric force sa pagitan ng Q, which is capital letter, at saka nung test charge, 'di ba? So, gawin natin 'yan, From the definition of the electric field, E is equal to the force per unit charge. Lagyan natin ng arrow to indicate vector quantity yan. And from Coulomb's law, we know that this force is equal to K times Q divided by R squared. Tapos, i-divide pa natin yan ng Q. Diba? Kopyahin ko lang to. So, dito sa expression na ito, obviously, magka-cancel itong Q. So ibig sabihin, itong test charge na ito, hindi ilalabas sa formula. Bakit? Kasi nga, nag-cancel siya. Yes. So, ano na lang ang matitira dito? Ang matitira na lang sa expression ng electric field is yung K, Q over R squared. Ayan, nakapag-derive na tayo ng unang formula ng electric field. This is the formula for finding the electric field of a point charge. And that electric field is equal to KQ over R squared. Ayan, kitang-kita natin ha. Kapag malaki yung magnitude ng source charge, malaki din yung electric field. However, yung electric field, kagaya sa Coulomb's law, meron din tayong R squared sa denominator, which means that the electric field is inversely proportional to the square of the distance. So halimbawa, dinoble natin yung distance. Anong mangyayari dun sa electric field? Eh di magiging 1/4 ng original. because it is subject to an inverse square relationship. Okay? Dito naglagay lang tayo ng unit vector, AR. That unit vector will indicate the direction of the electric field because once again, electric field is a vector quantity. Pero kung ayaw mo namang malaman ang direksyon, interesado ka lang sa magnitude, ito lang yung mahalaga dyan, KQ over R squared. So, we know that kung positive ang charge, assuming positive ito, di ba? Ang direction ng electric field ay laging palayo, away. So, halimbawa, at this point, the electric field is away. At this point, halimbawa, away pa rin, di ba? At this point, palayo. At this point, palayo. At this point, palayo. No? Kahit saang point, ang electric field ay laging palayo. So, you can now imagine how the electric field of a point charge looks like, no? So, mai-imagine natin, kahit saang point, laging palayo yung electric field. So, ganito yung magiging itsura niyan. Ayan. So, kahit saang point, ang electric field ay laging directed away from the source charge because it is positive. Okay? Now, not only that, pansinin din natin na magkaiba yung length nung arrows na ito. Di ba yung mga arrow na yan? Yan yung vectors na nagre-represent sa electric field. Because this point is closer to Q than this point, then dapat mas malakas ang electric field sa point na ito. Kaya mas mahaba yung arrow. Ito naman mas malayo. Di ba? At dahil siya ay mas malayo, mahina yung electric field sa point na ito kumpara dun sa point na mas malapit. Di ba? So, tatandaan natin ha, kapag point charge, ang electric field ay ganyan ang symmetry, no? Radial ang kanyang symmetry. Kapag positive, it is radially away from the source charge. Sir, what if this charge is a negative source charge? Eh di magre-reverse lang yung direction ng electric field. All the electric fields will be directed towards the negative source charge. Tatandaan, ang electric field ay directed away from a positive charge and towards a negative charge. Nagkataon lang na point charge ang pinag-uusapan natin kaya ang symmetry radial. Okay? So, radially outward or radially inward. At dahil invisible ang electric field, mahirap siyang aralin, no? Mahirap siyang pag-aralan kasi hindi naman talaga siya natin nakikita. So, the study of electric field is somewhat abstract. Unlike sa thermodynamics na madaling i-visualize ang mga bagay, 'di ba? Kaya nga, pag ang topic ay electric fields, it's best to visualize these electric fields in terms of imaginary lines. And these imaginary lines which we use to visualize the electric field, ang tawag natin dyan ay electric field lines. Okay? So once again, electric field lines are imaginary lines which are used to visualize electric fields. And the concept of field lines was also introduced by Michael Faraday. Okay? What are the properties of electric field lines? So first, alam na natin kanina, 'di ba, ang electric field ay directed away from the positive and towards negative charges. So anong itsura ng electric field lines? Yung electric field lines ay laging nanggagaling sa mga positive, no? At nagte-terminate naman sa mga negative electric charges. Halimbawa, meron tayong dalawang point charges. Yung isa positive, yung isa negative, kagaya nito. So makikita natin dito yung electric field lines. They are originating and emanating from the positive point charge. And they are directed towards the negative point charge. So in this case, meron tayong dalawang charges na equal ang magnitude. Kaya kitang-kita natin symmetrical yung electric field lines. Okay? Pero kung hindi equal ang magnitude ng dalawang ito, then hindi rin symmetrical yung itsura ng electric field lines natin. Papangit yan. Okay? And this configuration of electric charges, dalawang charges, yung isa positive, yung isa negative, pero equal ang magnitude ng charge, yan ang tinatawag natin na electric dipole. No? Sulat natin dito, we call it an electric dipole. So what is an electric dipole? It consists of two opposite charges having same magnitude, no, separated by a small distance. So we see here that electric field lines originate from positive and terminate on negative electric charges. Sir, what if both charges are positive? So if both charges are positive, then yung electric field lines mula doon sa dalawang electric charges ay parehas directed away from them. So, ganito yung itsura niya. Ayan. We have two positive point charges and we see that the electric field lines are all directed away from them. Okay? Now, what if these are both negative? O, mababaliktad lang yung arrow. Ganyan pa rin ang itsura para yung arrow papasok, no? Towards the negative charges. Okay? However, we notice that kahit na sila ay parehas palayo, hindi nag-intersect yung mga electric field lines. Yes, that is another important property of electric field lines. They never, ever intersect. Okay? Another thing, the number of field lines leaving or approaching a charge is proportional to the magnitude of the charge. Yan, anong ibig sabihin nito? Simple lang. Kung malaki yung magnitude ng charge, mas maraming electric field lines yung manggagaling sa kanya. Or kung negative, yung directed towards it. One more thing, kapag ang mga electric field lines ay magkakalapit sa isa't isa, kagaya dito, ayan, magkakalapit sila, ibig sabihin yung electric field doon mas malakas. Tapos dito, mas malayo yung pagitan ng mga electric field lines sa isa't isa. Ayan. If the electric field lines are far apart from each other, that indicates a weaker electric field. Tatandaan, kapag magkakalapit ang electric field lines, malakas ang electric field. Pag magkakalayo sila, mahina ang electric field. So makikita natin yan dito sa isa pang diagram na ito. Ito mas realistic, di ba? Kitang-kita natin, hindi drawing lang yung electric field lines. Yan, meron tayong dipole. Kita natin dito, dito sa region malapit sa charge. Kagaya rin naman dito, magkakalapit yung mga field lines. That is because kapag malapit ka sa charge, syempre mas malakas ang electric field. Di ba? Habang lumalayo, inverse square law, anong nangyayari sa electric field? Di ba humihina? Yes. Ganon din dito. Ayan. Pagka malapit sa charge, magkakalapit yung electric field lines, which indicates stronger electric field. Tapos dito medyo, ayan, magkakalayo na sila. Pagkakaiba lang nito dun sa kanina, hindi natin kita yung arrow. Di ba? Hindi natin kita yung arrow. Next. The electric field vector is tangent to the electric field line at any point. Ayan, halimbawa, dito sa point na ito, anong itsura ng electric field line? Tangent daw, ayun. At this point, for example, anong itsura ng electric field? Tangent, no? The electric field is always tangent to the electric field line. Sir, kapag uniform ang electric field, anong itsura ng electric field lines? Kapag uniform ang electric field, ang mga field lines ay straight lines. Parallel sa isa't isa at equal ang kanilang spacing. For example, ang electric field ay pababa, no, uniform. So, ganito itsura niyan. Parallel lines and lahat sila straight lines and equally spaced from each other. So, kapag ganyan ang drawing ng electric field line, that indicates a uniform or constant electric field. What if there are a number of source charges that establish electric field? No? How do we calculate the net electric field at a point? Electric fields obey the superposition principle. And because of that, we can add the individual electric fields generated by each of the source charges. No? Tapos i-add mo sila. Of course, using vector addition because electric field is a vector quantity. So the total electric field at a point due to several source charges equals the vector sum of the electric fields due to individual charges. So to write that in vector notation, the net electric field at a point is equal to the vector sum of the individual electric fields. So dito gagamit tayo ng vector addition. Okay, you can use component method or you can also use the unit vector approach kung saan ka mas convenient. Okay? So now, it's about time that we solve some example problems. Here's the first one.